So good evening, gentlemen. We have had a very good conversation on alternative fuels, and starting with a lot of beautiful dignitaries from Wärtsilä as well as from the DG Shipping, and they spoke at length about a wonderful concept of shore power, that is cold ironing, which we call. So the vessel will come, it will shut off all the engines, everything, generators will be shut, and it will get a supply from the shore power, which will be coming from the green grid. So now we move on to something of a mid concept. What is a mid concept is? The mid concept is biofuels that we are looking at right now. And we are going to talk of regulatory requirements. Thank you, sir. So we are going to talk from the regulatory point of view and what is the Indian perspective towards it. Okay? So the key takeaways will be, there will be a general introduction to biofuels, the types of biofuels, the IMO MARPOL Annex 6 requirements, the national policy on biofuels, that is from the government of India, then the biofuel potential and the summary of what we are going to talk of. So what is the IMO strategy? The IMO strategy is what we have spoken at length, that is 40% reduction by 2030, that is of CO2 emission, and 70% by 2050 of carbon dioxide in the air. And about GHG emissions, that is at least 50% reduction of GHG by 2050. So the strategy is that they will revise it every 5 years depending on the study that is being done. So what are the measures that we are looking at is, first of all, there are a short-term measures, a mid-term measures and a long-term measures. So first short-term is to initiate the research and development on activities on low and zero carbon fuels and innovative technologies. So this has been included in the MARPOL requirements, and this is what we are looking for. So what is the medium term is effective uptake of alternative low and zero carbon fuels. So first we will have a prototype testing of these fuels, then these fuels will be taken over into the second phase where they will be tested at length for the NOx emissions, sulfur emissions, as well as for the carbon dioxide and GHG gas emissions. And then the third part is the long term purpose is for zero carbon in the atmosphere. So right now the buzzword is going on is the life cycle analysis. So when we are talking of any fuel, what is the life cycle analysis? So from the development stage, right, from the plantation stage to the ship line, what is the CO2 production or what is the net GHG emissions of this particular life cycle of the fuel? So that is being talked about from the IMO side of view, and this is what it is all about. So we call it well to wake. So what are the types of biofuels? There are three types of biofuels in the jargons. That is the first generation, a second generation and a third generation biofuel. So the first generation biofuel is straight biofuel which we are taking from the vegetable oils or else hydrogenated vegetable oils. So all these soya bean, all these vegetable oil, sunflower oil, all the tallow oil, all the animal fat oil is all straight vegetable oil. What is the second generation? Second generation is used cooking oil from the restaurants which we get it, from the used lube oil which we get it, from the biomass, where there is a acute problem of stubble burning in India right now, which is producing more of carbon dioxide as well as the disturbing our atmosphere. So what if we can use this stubble in order to produce biofuel? Is there a method to do it? So that is coming under second generation of biofuels, and people are working on it at great lengths. So, and the third generation is from the algae. Now this is in a very nascent stage of development where the algae will be developed in the seashores, etc. And this will be used in generation of third generation biofuels. So what is the three aspects that we have to depend on is, first is the environmental aspect, which is the life cycle analysis, the land usage change analysis where the forests are being taken out to produce a crop. Say for example in Brazil we have had this, that the Amazon forest was destroyed for growing of sugarcane because of methanol production. So that is what is the environmental life cycle analysis. From the economic point of view, is it sustainable economically? Whether what can give rise to more of economic based cheaper fuels, which is better or good alternative to our fossil fuels, traditional ones. And what is the social cause? The social cause is where you have to have the atmosphere to be a lot more greener as well as a lot more feasible for carbon reduction as well as nitrous reduction. So what is the regulatory perspective in this regards? Is Annex 6. The air is being regulated by Annex 6. And what does it talk of from the biofuel perspective is Regulation 3.2. It provides for the trials of the ship, emission reduction and control technologies research cooperation with the Indian flag administration. So we have had a lot of ship owners come to us in order to use biofuel technologies, and we have, in cooperation with our DG Shipping, we have done trials of biofuels on various vessels. So these biofuel blends have not only been with MGO, that is the marine gas oil, but also from the traditional or hardcore HFO, that is heavy fuel oil based also. And these trials have been very, very much successful. So the trials, let me tell you, it has been with the help of used cooking oil, and it has been very successful in this case. So reduction of Regulation 18, it calls for the fuels produced by any other method other than the hydrocarbon blends is to comply with the sulfur content of 0.5%, which the biofuels very well do it. And NOx emission norms have to be fulfilled. So for NOx controls, we need to test every engine for NOx emissions when they are using biofuel as compared to that of the traditional MGO or heavy fuel oil. What about Regulation 13 is the revised NOx technical code. It talks of the data to be collected for further usage. And also Regulation 18, that is fuel oil quality, is compliant fuel is to be available at all ports. So availability of the fuel is a issue. So what are the challenges that we are facing is IMO guidelines of life cycle analysis will act as a precursor to the future fuel. So IMO is in the process of making this life cycle analysis. So blended biofuels, the current engines may have a low life cycle emissions. That is what has been seen. What about RM and the DM grade fuels have been tested to ISO 8217 standards, which limits the FAME content, which is a biofuel is mostly seen that the FAME content is high. But hydrogenated vegetable oil, which is HVO, the FAME content is not there. And that is why the biofuels is been tested to ASTM D7467 standards. Now, for the influence of NOx and the CO2 emissions, the IMO requirements, that is the SIMP requirement part 2 as well as for the CII requirements, there is no particular weighted average component or any CF component for the carbon emissions in the IMO requirements. So that has to be incorporated for biofuels so that we can use more of biofuels into the system. So what about biofuel usage on board is onboard ship storage. The following is to be ensured. The monitoring of the storage tanks for the water content and microbial degradation of this fuel takes place. So there is a expiry date for these biofuels because of if there is a content of oxygen and water, it will degrade very quickly. The water bottom measurements is to be at appropriate frequency. The water drainage from the fuel tanks is to be regularly done. It is recommended to take liquid samples from the bottom of the fuel tanks for measurement of basis once every month. Periodic monitoring of the tank condition to avoid a buildup of dirt and rust. So material compatibilities, there is some problems with biofuel, which is it is not compatible with some of the metals, and so the compatibility of biofuels is to be verified. So biofuels degrade some hoses, gaskets, seals, elastomers, glues and plastic after prolonged exposure. Also the storage material. Lead, tin, brass, bronze and zinc significantly increase sediment formation when in touch with biofuels. So we come to the adage is saying that we have to think global but we have to act local, and this is what the act local part of it is, the Indian perspective. So we have a national biofuel policy, the national policy on biofuel. This was made in 2008 and has been mostly implemented in a very structured manner by the Ministry of New and Renewable Energy. So what it says is that the strategy and approach is non-edible oil seeds are to be used for production of biodiesel and bioethanol. So plantations on agricultural land is discouraged. So mostly the wastelands and the not edible lands are to be taken for the production of these non-edible seeds. 400 species of trees bearing non-edible oil seeds in the country have been identified. Advanced conversion technologies for biofuel has been looked into. The technologies for end-use application, including modification and development of engines, has been looked into. So, import of fatty acid oils will not be permitted for production of biofuel. So, first and foremost, all the oil which is imported, 80% of the oil which is imported in India is used for personal consumption. And so, if we are using it for biofuels production, it will be having a cost effect on the society. So, that is why the import of biofuels is been totally stopped. The Bureau of Indian Standards has a biofuel B100 testing requirements which have been produced already. So now state-wise potential of used cooking oil potential. So it is coming around 300 kilotons, that is almost 300 tons of used cooking oil is produced in the country, which is going for out now incineration. Instead of incinerating it without any production of any energy, this energy has been lost to atmosphere. We can use it for production of oil, which can be used for the ship propulsion. And so this is thanks to our Council of Indian Scientific and Indian Research, CSIR. We had a very lengthy discussion with them. IIP Dehradun and Dr. Anjan Ray was very helpful in giving all this knowledge to us, and that is why we came up with all these requirements and knowledge. So there is a tree-borne oil potential and exploration. So tree-borne oil, if you see here, the number 2 and 3, which are traditional requirements, are neem and mahua crops in India. They are grown in wastelands. They produce a lot of seeds, and the oil content of these seeds have a high potential for production of biofuels. And these plants will keep giving seeds, and the production of biofuel will be that much amount of effective. And these plants can be grown in wastelands, in not so agriculturally producible lands, and they can help us green the atmosphere. So biofuel trials on board, we have been corresponding with all the manufacturers or the owners, ship owners, for the biofuel trials with the help of DG Shipping, and we have already tested a couple of vessels on biofuel, B20 right now only, and we have had a very successful results with reduction in NOx, reduction in carbon dioxide emissions, and we are further taking it ahead, and we are testing it with the requirements of HFO. Now blending with HFO also has been done with B20, and we have got very good results. Right now, what has the latest news is that the Canadian company called CDS has already done B100 testing of biofuels, and it has got reduction in NOx. They have printed a paper in which is in IMO right now, and they have got a very good results of biofuel, NOx reduction as well as carbon dioxide. So coming back to here, the potential effects of biofuel blends in the range of equipments like engines, oily water separator and purifiers, that is what we do for the owners. We test the biofuel samples, verification of the bunker delivery note we carry out. Then we check for the total acid number as the blended ratio increases, leading to corrosion in the engine components. We check for the NOx emissions on board, and a detailed procedure will be submitted for scrutiny and the DG Shipping approval. So the detailed planning of onboard measurements of the ship owners is forwarded, and after a review, we do a review of the NOx production. The statutory authority for approval, the vibration is measured for the engines, because sometimes you can have a little bit of knocking or any issues with the engine if it is not tuned in correct order. And also the crankshaft and foundation levels are checked with the OEM requirements. So engine manufacturers have to be hand-holding from the engine manufacturers required for any new trials to be carried out, and that is what we have been doing right now. So in order to further summarize the system, FAME biofuel biodiesel is used in blending them with fuels. It is reported that B100 pure FAME have been successfully trialed right now. So zero carbon emissions, definitely. Significantly reduced SOx, yes, there is sulfur content is negligible in this. It meets the requirement of 0.5% which the IMO is prescribing, and the aspect is to be checked for NOx, and the NOx reduction has been significant right now with B20 blends. This for the HVO, that is hydrogenated vegetable oil. This has been trialed successfully, and it has been giving excellent results. Thank you, ladies and gentlemen. Thank you for your attention. Thank you, sir.
I'll be here, so you have it. Thank you, Siddhesh. It was a very insightful presentation, and you threw light on biofuel. It was really something to know about, and generally we don't discuss such things in the forum, but what the inside research, etc., that you have portrayed was really amazing.
Thank you, sir.
Great job. So the floor is open for Q&A. So first opportunity must be given to the audience present here, and then I have some questions that I will ask a little later. But the first over to the audience. Any questions? Anybody? Please raise your hand. Audience, yes. All fundamentals are clear now. No questions. So yeah, I have some questions, Siddhesh.
Yes, sir.
You are at the helm, so the people are there, not there from Flag, and I think they cannot hear us. The people who are online. So yeah, but you are at center. In fact, class is at the center. So class is coordinating with the owners, class is coordinating with the makers as well as the Flag. So few questions which are, I would say, owner's perspective. So. Just data-wise, what is the Indian flag vessel status in terms of future ready? Like January 2023 is not far away, just 6-8 months away. So what is the, like, how many percentage of the fleet, of Indian fleet is ready, future ready? Any idea on that?
So right now, we have got very limited kind of a coverage area for this one. We have tested very, very few vessels on biofuels, yes.
Yes.
There are 2-3 companies which have come forward. There have been new building wise, there have been lot of approach coming from the perspective, because this emissions requirements are very stringent for them, the new building wise. So new building wise, they are trying from fuel cell point of view for the small vessels. From the hydrogen point of view, we are dealing with one hydrogen fueled vessel which will use a fuel cell kind of a system producing electricity, and then producing the produced electricity will be used for running the electrical propulsion system.
Right.
So those niche systems, solar powered vessels, we have already done, and those niche systems are being used in a very small scale, small vessels. Right. So once these prototype small vessels are acting and behaving in a certain manner for a prolonged period of time, the confidence building phase is done. Then I believe that the bigger players will come into this playing field, and they will try out all these technologies which have been given by us right now.
Yeah. Thanks, Sanjay. Sorry, Siddhesh. It was a great answer, and I think it was useful for the people audience here. See, IMO strategy is like quite demanding, as you have seen. From your perspective, I mean, from class perspective, how much it is achievable and practical?
It's a very difficult question to answer.
I'm owner, so I have to know the.
So, from the class perspective, we have to follow what is given from top. So it is a top-down approach. So when they are going, this strategy is very critical.
Yeah.
But every 5 years, they are going to go back to the drawing room, and they are going to understand where we have reached from the starting point and what we have done. So right now, we are trying everything. We are trying biofuel, we are trying methanol, we are trying gas, LNG, LPG, we are talking of methane slip, we are talking of everything right now. So in case of 5 years time, the next phase, we will come to a conclusion that this is better and this is better from the other ones. So we have to eliminate a few of the players, and then we have to see to it that only a few players are running. Now LNG, there has been paper produced that methane slip is causing greenhouse gas effects, and then there has been corresponding, again paper have been produced that no, methane is the next big thing. Methane based fuels are the next big thing. So we have to understand the concept, what is being said, where it is being said, from where it is coming from, and we have to make a truly better choice for the environment where we are going to right now.
So what is your gut saying? I mean, which fuel? We have so many options.
Yes, sir. So mid-term biofuel, I guess it is the best one for the marine industry, Because right now we are not only playing from the marine, there is aviation industry, which is the biggest polluter of all. So
Correct.
aviation industry has already moved to biofuel.
Biofuel, yeah.
Correct. So aviation industry has moved to biofuel. There is also the land-based usage. So we are also competing with land-based usage, and so these land-based usage and the aviation industry are the forerunners for us. We are the last ones to get a representation. And also, where there is a demand, there is a big debate between the food versus fuel debate. So there, the biofuel produced from all these second generation fuels will take a precedence. That is what I think.
I will say it's a good information for all the owners who are in dilemma and that which fuel option is appearing to be more promising. I mean, you can clearly see from the research that has been done. Biofuel looks indeed quite promising. Not that other fuels are ruled out options. They are having their own advantages. One more question, and that will be the last question. Okay, fair enough. So, Mr. Verma is also available. So, maybe one question to you, and then I'll ask Mr. Verma. So, one more question. Like, is class providing some kind of advisory to the ship owners? Exclusive cell is there with class?
That's correct, sir. So we have plan approval division. Mr. Devrup Kabi is heading the division, and he is assisting the ship owners with everything regards to alternative fuel technologies for the trials, etc. Yes, sir.
Wonderful. Thank you so much.
Thank you,
we
sir.
know that we have a dedicated cell with classification society, almost each classification society. Of course, IRS is our Indian classification society, which we can approach anytime. Thank you so much, Siddhesh.
Thank you, sir.
Thank you. So, Verma sir, are you able to listen to me? There is a delay of 20 seconds, so we'll wait for him to respond. Over to Mr. Sanjay Verma. Am I audible to you?
Yes, I can listen to you.
Okay, sir. So, my first question to you, sir, how
Did you hear
owners should go about doing the technical feasibility before going for any retrofit? How they should proceed? From where to start?
Yes, this is a very good question, and general tendency of the owners to comply with EEXI is directly to go for an EPL, which I understand that it's the easiest and cheapest way, but not the sustainable way. And once you apply the EPL, then you are limiting the capability of your vessel. That is a very, very clear message that you will reduce the capability or speed of the vessel. Now, if by applying the EPL, they are not going into the zone where the ship is required to operate, it's fine. But most often, I have seen in cases of hundreds of ships that at least they are limiting some capacity. So that means they are less attractive to the charterers. So the first thing that they should look at that the ship in totality, not the same thing will apply to all the ships. So they must know where each ship of theirs is standing in terms of EEXI, at the same time CII, so that they can make the improvement, because EEXI is one time, but CII is going to remain with them for the next 10, 20 years.
Right.
And it is the tougher one. EEXI is the simpler one. And when you apply something, then you also need to see if you are getting benefit. So each ship you have to look at its age, what kind of capex you want to invest there, and when you need to invest it, because certain modification can only be done during dry dock. Certain things can be done without going to dry dock. So they need to look at the ships individually and not like, I want to apply this to my fleet. That is not a solution. Age-wise, because a shaft generator, if you want to put a shaft generator on an existing vessel, it is a high capex thing. But it is going to give you reward both in terms of CII and EEXI. So many EEXI you can meet without even doing EPL. So that is one thing which is very, very important, to not look at their entire fleet, but look at ship individually based on their age, based on their present EEXI and present CII, how they are going to manage the transition and how they are going to keep their asset earning for the next lifetime of the vessel. Yeah, that would be my answer. Sorry, I know there is a time lag, so this is how I can present it.
Thank you so much, sir. It was really insightful and useful for the industry people to know about how to proceed with the compliance, regulatory compliance, as well as technically how it is to be implemented. Like, so thank you so much, Mr. Verma. Thank you so much. And is there any still question? Yeah, I think we have a question from audience. So can you give the mic? Yeah, please introduce yourself.
Yeah, good afternoon. It's great listening to the experts here from the shipping industry. My name is Deepak. I come from Simerix, a company we are involved in engineering simulation, based out of US, and here we have the office in India as well. Particularly, we help the automotive industries and the shipping industries in designing the propulsion system. So my question related to the propulsion system. I heard Mr. Verma talking about different fuel options, where you talked about methane or ammonia are the immediate solutions, and Wärtsilä has already built up the propulsion system based on that. But when it comes to hydrogen, storage is a big issue, as you said. But if I look at the automotive industries, particularly big names like Toyota or GM or Cummins, they are getting into hydrogen energy. But electrification to hydrogen engine, particularly for the trucks and buses. So how do you see the difference between the land transportation and the water transportation in terms of propulsion engine in the context of hydrogen engine, say for instance? Because as you said, hydrogen is not a good option so far. But the challenges are same, like hydrogen storage or water management in a fuel cell, whatever you name it actually. So challenges are same. So that's my question. Thanks a lot.
Thank you, gentlemen. Thank you so much. Over to Mr. Verma. There's a gap of 20 seconds, so bear with us.
Thank you. I heard the question, and it's an interesting one. I will just give an example of, you took car industry as an example. Now, when you have a car, how often do you see a gas station to fill up your car? But if you are looking at a ship, when you leave a port, and when is the next port coming where you could bunker? That is the first thing. So the proximity of bunkering, the type of the vessel, I did not say that the hydrogen will not come on a ship. It will come, but it will come on maybe river transportation, coastal transportation, and also what type of ship it is. If it's a tug, I gave an example of a tug. If you put hydrogen on a tug, you don't have any place to do business. You can't put the winch there. Then a tug without a winch is not a tug. Similarly, if you are looking at a bulk carrier, and a bulk carrier is operating transatlantic, if you put all the hydrogen, then where is the place for carrying any cargo? Because it will require that kind of a space to store, a passage from, say, China to Australia. So the bunkering, how often can you bunker it? Where is that? Where is the, what is the type of the vessel? This will all dictate. There are hydrogen ferries. There are hydrogen ferries running inside the port. Yes, where you can have a compressed hydrogen bottles, and you can change after every 2 hours, after every 1 hour when you come back to the port, you change the bottle. Yes, you can do it, but you cannot do it on an ocean-going vessel. That is how I would answer this question. And then again, liquefying it and keeping it on board. The cost of that cryogenic container itself make it such that a prohibitive cost of the storage. It is expected, it cannot be kept in the double bottom tank. You need special steel tanks and the insulation minus 253 degrees to 34 degrees outside. The kind of boil off that you would have, to contain that boil off, you will need a liquefaction process. And that liquefaction process again will consume so much energy that you will become energy inefficient ship. Thanks.
Thank you, Mr. Verma. Thank you so much. It was a well answered. I think you are satisfied. Any other question from the audience? Any other question? Okay, time's up. So, thank you, the organizing committee and team. Over to you again, because we have ended with the session, and it was really good, enlightening. Thank you so much.
Okay, since I don't have much of an option here, I think you both have to felicitate each other. It's a give and take relationship over here. So, like I say, it's a good thing. And we are glad that even people from Singapore, etc., even though virtually and even though with the 20 seconds gap, at least we could go ahead with that. Even with small glitches, the jugaad should remain. Yeah. The jugaad is always on. So yes, sir, I request you to felicitate. So Mr. Siddhesh Prabhu, please felicitate Mr. Sunil Kumar, and Mr. Sunil Kumar, please felicitate Mr. Siddhesh Prabhu.